In this video, you will learn how to multiply monomials. So to know how to multiply monomials, there is one rule that is necessary to understand. So I'm going to show you how this rule works, and then we'll generalize this to come up with the mathematical expression of this rule. So here we have our illustration. We have x squared times x to the fourth power. And we are told to simplify or combine this. Well, x squared means we have two x's. X to the fourth means we have four x's. That's all being multiplied together. So here we see two factors of x. Here we see four factors. So altogether there are 6 factors. So when I write this, I can write this together as x to the 6th power because we have 6 x's being multiplied together. Alright, now we don't want to have to write this out every time. We don't want to expand and have to write every x that we have over here. We want to know how to get from x squared times x to the fourth directly to x to the 6th power, skipping over this intermediate step. So notice, to get from 2 and 4 over to 6, we simply add 2 plus 4. So that is the rule. The rule says that if the bases are the same, and I'm multiplying, that I add the exponents. So I add 2 plus 4 to get 6. Now in general, here we see this expressed in math notation. So we have a to the m power times a to the n power. So this means here we have m a's multiplied together. So here we have m factors of a. Here we have n a's multiplied together. So we have n factors of a over here. So together we have m plus n factors, and we can express this as a to the m plus n power. So the rule says a to the m power times a to the n power equals a to the m plus n power. So as we stated, in other words, when you multiply and they have the same base, you simply add the exponents. Now here we have multiple examples illustrating this concept. Here we have x to the 2nd power times x to the 6th power. So we're multiplying, the base is the same, so I can add the 2 and 6 to get 8. So my expression would be x to the 8th power. Here we have b to the 5th power times b squared. Because I'm multiplying, I can add the exponents, 5 plus 2 to get 7. So this can be written as b to the 7th power. Next we have 3m cubed times 4m to the 4th power. So we have put together numbers along with the variable and exponent expression. So what I can do is take the 3 times 4 right here to get 12. So we have 12. And then look at the m's. We have m cubed times m to the 4th power. So when I multiply, I add the exponents, 3 plus 4 to get 7. So this would be 12 times m to the 7th power. Here is another example where now we have negatives thrown in there, and we also have more than one type of variable. So same thing, the negative 2 times 5, those can combine to get negative 10. So we have negative 10, and then the a's, we have 3 a's, and then one more a here, a to the 1st power. When I multiply, I add the 3 plus 1 to get 4. So I have a to the 4th power. And then the b's, we have b squared and b to the 3rd. We're multiplying, so we can add the exponents, 2 plus 3 to get 5. So my expression would be negative 10 a to the 4th times b to the 5th power. Next we have an illustration with fractions. So here, with fractions, remember anything on the top I can divide with anything on the bottom. So the 30 right here can divide with the 5 on the bottom. So 30 divided by 5 is 6, or 6 over 1. And then 14 can divide with the 7. That gives me 2 over 1. So on the top, I have 6 times 2, which would give me 12. And then we have 4x's times 3 more x's, which gives me 7x's. So I add the exponents. And then for the y's, we have 1y here times 2y's here. Now that gives me 3y's. So this expression can be simplified as 12x to the 7th times y to the 3rd power. And here we see one last example. Now here, be careful with the plus sign. Okay, we are adding these two things together. And so I need to do this separate from this over here. Alright, so on the left side, when I simplify, I do the 3 times -2, which would be -6. Look at the a's. We have 4 a's times 2 more a's, so that gives me 6 a's. So a to the 6th power. And then the b's, we have 6 b's, and then times 1 b. So together we add the exponents, and that gives me 7 b's. So b to the 7th power. And then the second expression over here, 8 times 1 is just 8. So we have 8. Then the a's, we have 3 a's here, 3 a's here. Add the exponents, 3 plus 3 to get 6. So we have a to the 6th power. And then the b's, we have 2 b's, and then 5 more b's. And that gives me 7 b's, or b to the 7th power. And then here, we can look to see if we can combine anything. And we actually can, because these would be like terms. They both have a to the 6th, b to the 7th power. So those are like terms, so I can combine. If they were not like terms, then my answer would have to remain as it is. But they are like terms, so I can combine. We have -6 of these plus 8 of these. So -6 plus 8 would give me a +2. So I have 2 as my coefficient, and then a to the 6th times b to the 7th. So this right here would be my final simplified form of the initial expression. And that concludes our lesson for today. We will see you next time.